Though you will see click to continue and replay buttons in this video, these features are not supported by this format. You may want to pause the video when you see these buttons. If you want these features and the supplemental slides and files that correspond to the video, then enroll in the course at biztricks.us. I'll talk about strings more quickly because you now know how the framework behaves with dates from the previous lesson. I'll use a few simple examples to review strings. I begin by measuring string equivalency. In this example, the values are not equal because the second value has a leading and trailing space. I'll remove the spaces with the trim function and try again. What about case sensitivity? Even though the casing is different, these values are equal. So I'll examine why, because I would have expected these to not be equal. As the site states, collation determines the rules that sort and compare character data. There are options to manage case sensitivity, accents, and more. I won't discuss this in detail because you can go through the site on your own. As you scroll down, you'll notice that each locale has a default collation. United States English has a collation of SQL Latin 1 General CP1 CI AS. I'll confirm that with a query. CI is case insensitive and AS is accent sensitive. If I change the case insensitivity to case sensitivity, then I get the answer I was expecting. In my opinion, collation settings are why database administrators should almost always default to integers rather than strings for primary keys, because a bad assumption regarding the collation will yield a potentially wrong result. It is possible to use strings for primary keys, but this should be done only if you follow rules that will eliminate the opportunity to create differences in equivalency. Assuming you have case sensitivity for your default collation, then you can use the lower or upper functions to switch all the characters to the same case.